Hello, today we are going to be covering lesson 6.5. This is about rhombi and squares. You guys will be able to recognize and apply properties of rhombi and squares and determine whether parallelograms are rectangles, rhombi, or squares. We have a new vocabulary, rhombus and square, and here we go. So a rhombus is a parallelogram with all four sides congruent. You'll notice that here, all four sides are congruent. A rhombus has all the properties of a parallelogram, that's pretty important to note, and two additional characteristics described in the theorems below. So we know two things about the diagonals. We know if a parallelogram is a rhombus, then its diagonals are perpendicular. They must cross at 90 degrees. And we know if a parallelogram is a rhombus, then its diagonals bisect a pair of opposite angles. So bisect means it cuts them in half. That means because opposite angles are congruent of parallelograms, that means they are also in rhombuses. And if they bisect, 3 and 4 and 1 and 2 are all congruent, and the other diagonal also bisects its angle, so 5 and 6 and 7 and 8 are congruent to each other. So we're going to use those ideas to be able to solve over here. This states that the diagonals of a rhombus WXYZ intersect at V. That's pretty good to know. And then we are going to find missing angle measures and then find the value of X. So we know that the measure of WZX is equal to 39.5. And we are trying to find the measure of angle ZYX. So a good thing to note here is in parallelograms, if you recall, that corresponding, or consecutive, I should say, consecutive angles add and equal 180. So we're going to use that right here. We also know that in a rhombus, diagonals bisect each other. So this guy here is 39.5 because these two must be congruent. So we take 39.5 and add it to itself, and we get 79. Then if we want to find this missing angle here, we know that consecutive angles add and equal 180. So we solve and we get that the measure of angle ZYX is equal to 101 degrees. And then perhaps even easier is solving for the value of X. We know in a rhombus all side lengths are congruent. So we can go ahead and say that WX is congruent to WZ, as well as XY and YZ. And then we just set them equal and solve for X. And then we have our solution for X is 4. The next problem, similar, although A is different angles, they're not exactly the same. We know ABCD is a rhombus. We are going to find that the measure of CDB, given that the measure of ABC is 126. So if you recall, the measure right here, this little guy, would be half of the whole shape because our diagonal BD bisects it, so this would be 63. You can think of this a couple different ways, that these two are either alternate interiors, or you can recall that these four are all congruent to each other as is. So we know that the angle we are trying to find, the measure of angle CDB, is 63 degrees. And then part B is very similar to the last part B, where we simply say BC and CD are congruent and set them equal and solve. Alright, so now we're moving into squares a little bit. A square is a parallelogram with 4 congruent sides and 4 right angles. Recall that a parallelogram with 4 right angles is a rectangle, and a parallelogram with 4 congruent sides is a rhombus. Therefore, a parallelogram that is both a rectangle and a rhombus is a square. So if you look down here at this nice little chart, we have the overarching parallelograms. They just have opposite sides parallel. And then within that group here, we have rectangles. They have 4 right angles. We also have rhombi that have 4 congruent sides. And when we have both of those things, they come together in our Venn diagram, and that is called squares. So a rectangle, or a square is a rectangle, a square is also a rhombi. So we have some theorems here. We already saw a couple of these. If the diagonals of a parallelogram are perpendicular, notice we must first know that these are all parallelograms. If we don't know that they're parallelograms, then we're wasting our time. We must know that they are parallelograms. If the diagonals are then perpendicular, then it is a rhombus. So if we know it's a parallelogram, the diagonals are perpendicular, it must be a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if we just have one diagonal, not two, and the diagonal is bisecting the opposite angles, we know that it is a rhombus. And if we have one pair of consecutive sides of a parallelogram, so if two sides that are touching each other right beside each other are congruent, then we know that this is also a rhombus. We don't need to know that all four are congruent. We can just know that two consecutive are. So, lastly, this one's about squares. If a quadrilateral is both a rectangle and a rhombus, then it is a square. So we're going to do a quick proof here. There's not one on your homework. We are going to prove that LMNP is a rhombus given that LMNP is a parallelogram. And we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 6. So I'm going to mark those out. This one, we are not trying to prove one of our new theorems. That would be a longer proof. We are just going to use our new theorems here and assume that the theorems are true. So, for our second step, we are going to say that LN, that segment, bisects the angles. Angle PLN and angle PNM. And that's just definition of a bisector. Okay? And then we're actually ready to finish, because if we look back up at our theorems, we can go ahead and say that LMNP is a rhombus. If we look at our theorems, that would be by theorem 6.18. If we look up here, 6.18 tells us that we can have one diagonal in a parallelogram bisect a pair of opposite angles. So I'm going to put that in parentheses because that's better for me to remember what actually happens than just the theorem number, which might be different numbers at a different school. So I'm going to say a diagonal bisects opposite angles. And call that good. Pretty simple proof there. All right, this next one we're not actually proving, and there is a typo here. We want to say ABCD, not ADCB, D. We're going to look and see, is there enough information given to prove that this is a rhombus? Now, once again, this is another one of our theorems. ABCD is a parallelogram. We know that AD and DC are congruent. Those are consecutive sides. So those are right side by side. So we know that by theorem 6.19, and I'll explain once again, consecutive sides of a parallelogram are congruent. And then I'm good to go. All right. Now these last two, we are going to take what we know about these parallelograms. Notice we know it's a parallelogram before we even start. And then decide if it's either a rhombus or a rectangle, or all three a rhombus, rectangle, square. Because if it's both a rhombus and a rectangle, it's also a square. Okay? So there is a shortcut way or the long way. The long way is basically just finding the distance of all the sides and saying, okay, they're all congruent, so it must be a rhombus. And then finding the slope of all the sides, and if they're opposite reciprocals of each other, then we can say, okay, they're 90 degrees, it's a rectangle. Now, our shortcut, if you recall from our rectangle section, we learned that diagonals must be congruent for this to be a rectangle. And then today we just learned that for it to be a rhombus, we must have 90 degrees between our diagonals. So that is our shortcut way, one of our shortcut ways. I'm going to do it that way. I'm going to cut my steps from 8, the long way, down to 4. So I'm going to find the distance of my diagonals to check and see if it is a rectangle, and then I'll find the slope to check and see if it's a rhombus. So the distance formula, I'm just going to do this out. You can follow along, pause me if you need to. Then I'll find my distance of my other diagonal. Now you will have some like this on your homework. I would suggest drawing a sketch of a coordinate plane, so that way you know which 2 points to pair up as your diagonal. All right. So I ended up getting square root of 34 for this. That means our diagonals are the same, so this is definitely a rectangle because the diagonals are the same length. Now to check to see if this is a rhombus, I'm going to find the slope of my diagonals. So I'm going to find the slope, or M, of BD. Changes in Y's over changes in X's. And then hopefully these are opposite reciprocals of each other. If they're not, it's only a rectangle, and if they are, it is a rectangle as well as a rhombus as well as a square. Oops, sorry. There we go. Y's first. I got ahead of myself, sorry. There we go. So these are opposite reciprocals, so we know it's also a rhombus. And then if it's both of those, then it is also a square. Okay? We're going to try one more. I'm going to show you another shortcut way. The shortcut way that we're still going to use for the rectangle is the fact that the diagonals must be the same distance, but this time I'm going for the rhombus. I'm going to check that consecutive sides are congruent. Any 2 consecutive sides should be congruent for this to be a rhombus. So I'm going to do the distance formula 4 times. I'm going to find the distance of GE. I'm going to find the distance of FH. Those will tell me if it is a rhombus. No, sorry. Those will tell me if it's a rectangle. Then, if the consecutive sides are congruent, this will tell me if it is a rhombus. If they are, then we'll have a rhombus. So I'm going to try all these. GE to start. Follow along. Once again, pause me if you need to. All right, so it checks out to be at least a rectangle. Now I'm going to check consecutive sides and see if these are congruent in making it a rhombus. One more to check. All right, looks like once again that these are the same, so it is a rhombus as well, making it also a square. I will tell you that won't always work out. Sometimes these won't end up being the same, so it will only be a rectangle. Sometimes this won't work out and it'll only be a rhombus. It really just depends. So real quick, one last thing. Like I said, we must know that these are parallelograms before we even start, because you could have two consecutive sides congruent like this. Not exactly congruent, but not to scale. Anyway, then if we don't know that it is already a parallelogram, the third and fourth side could be something like this. That's definitely not a parallelogram. It's also definitely not a rhombus, even though consecutive sides are congruent. So we first must know parallel, and then we can try to decide if it's a rectangle, rhombus, or all three, including square. All right? One last thing, I want to show you this quadrilateral flow chart on Canvas. You can see that we have quadrilaterals at the very top, the biggest overarching. Then we have the different breakdowns, so everything about a square. We also know squares have the qualities of a rectangle, rhombus, parallelogram, and quadrilateral. Rectangles only have their own and parallelogram and quadrilateral qualities. Parallelograms only have their own and quadrilateral, so you can like work upwards and know different parts that are true about each thing.